Hello, and welcome to my channel, A to Z of heat treatment terminology, abrasive blasting. A pressurized stream of hard metal or oxide grit material used to clean and/or roughen surfaces prior to coating. Abrasive wear caused by hard sharp particles. Acicular ferrite. A highly substructure no equiaxed ferrite that forms upon continuous cooling by a mixed diffusion and shear mode of transformation that begins at a temperature slightly higher than the temperature transformation range for upper bainite. It is distinguished from bainite in that it has a limited amount of carbon available. Thus, there is only a small amount of carbide present. Adhesive wear caused by sliding surfaces, where surface asperities interact and adhere. Age hardening. Hardening by aging, usually after rapid cooling or cold working. Age softening. Spontaneous decrease of strength and hardness that takes place at room temperature in certain strain-hardened alloys, especially those of aluminum. Aging is a structural change, usually by precipitation, that occurs in some alloys after preliminary heat treatment or cold working operation. Aging may take place in some alloys at room temperature in moderate time, days, or in others may be done in shorter time at furnace temperatures. Overaging may be done at a temperature above normal to produce some desirable modification. AIR hardening steel. A steel containing sufficient carbon and other alloying elements to harden fully during cooling in air or other gaseous mediums from a temperature above its transformation range. The term should be restricted to steels that are capable of being hardened by cooling in air in large sections, about 2 inches, 50 millimeters, or more in diameter. Same as self-hardening steel. Aluminizing. Forming a corrosion and oxidation-resistant coating on a metal by coating with aluminum and usually diffusing to form an aluminum-rich alloy. Annealing. A very general term describing the heating of metal to a suitable temperature, holding for a suitable time, and cooling at a suitable rate to accomplish the objective of the treatment. Annealing may be done to A. Relieve stresses, B. Induce softness, C. Improve physical, electrical, or magnetic properties. D. Improve machinability. E. Refine the crystalline structure. F. Remove gases. G. Produce a specific microstructure. Annealing carbon, fine, apparently amorphous carbon particles formed in white cast iron and certain steels during prolonged annealing. Also called temper carbon. Annealing. Twin, a twin form in a crystal during recrystallization. Anneal to temper, a final partial anneal that softens a cold, worked non-ferrous alloy to a specified level of hardness or tensile strength. Anodizing, the production of an oxide layer on aluminum alloys. The process is electrolytic, a typical electrolyte being sulfonic acid. Treatment at room temperature produces thin, decorative layers with some corrosion protection. Treatment at 0 degrees Celsius produces hard, thicker layers, up to 100 micrometers, with wear resistance. They can be post-sealed to give improved corrosion resistance. Artificial aging, aging above room temperature. C-aging, compare with natural aging. A thermal transformation. A reaction that proceeds without benefit of thermal fluctuations, that is, thermal activation is not required. Atmosphere. The gaseous environment in which the metal being treated is heated for processing. Atmospheres are used to protect from chemical change or to alter the surface chemistry of steel through the addition or removal of carbon, nitrogen, hydrogen, and oxygen, and to add certain metallic elements such as chromium, silicon, sulfur, etc. Austempering. A heat treatment for ferrous alloys in which a part is quenched from the austenitizing temperature at a rate fast enough to avoid formation of ferrite or pearlite, and the held at a temperature just above MS until transformation to bainite is complete. Austenite is the name given any solid solution in which gamma iron is the solvent. Austenite is a structure name and means nothing as to composition. Austenite is the structure from which all quenching heat treatments must start, which is characterized by a face-centered cubic structure. Austenitizing the process of heating a steel above the critical temperature. Bainite. The product formed when austenite transforms between 450 degrees Fahrenheit and 900 degrees Fahrenheit. Bainite is an acicular aggregate of ferrite and carbide and varies in hardness between Rockwell scale 30 and 55. Baking: 1. Heating to a low temperature to remove gases. 2. Curing or hardening surface coatings such as paints by exposure to heat. 3. Heating to drive off moisture, as in the baking of sand cores after molding. Bark, an older term used to describe the decarburized skin that develops on steel bars heated in a non-protective atmosphere. Blasting, a pressurized stream of some materials, glass, plastic, metal, etc., applied on a surface to clean and/or roughen. It can be, depending on the media, abrasive, a non-abrasive. Blue, annealing. Heating hot rolled ferrous sheet in an open furnace to a temperature within the transformation range, and then cooling in air in order to soften the metal. The formation of bluish oxide on the surface is incidental. Bluing. Subjecting the scale-free surface of a ferrous alloy to the action of air, steam, or other agents at a suitable temperature, thus forming a thin blue film of oxide and improving the appearance and resistance to corrosion. Note: this term is ordinarily applied to sheet, strip, or finished parts. It is used also to denote the heating of springs after fabrication to improve their properties. Bond strength. The strength of the adhesion between the coating and the substrate. A few test methods are in use to measure the bond strength of coatings. Boronizing the diffusion of boron into the surface of a component, usually steel, by a high temperature, approximately 9,000 degrees Celsius, gas or pack process, produces hard phases within the surface, typically 100 micrometers deep. Bright annealing. Annealing work in a protective atmosphere so that there is no discoloration as the result of heating. In some atmospheres, oxides may be reduced. Brittle tempering range. Some hardened steels show an increase in brittleness when tempering in the range of about 450 degrees Fahrenheit to 700 degrees Fahrenheit, even though some tempering causes some softening. Carbonitriding. A case hardening process in which a suitable ferrous material is heated above the lower transformation temperature in a gaseous atmosphere of such composition as to cause simultaneous absorption of carbon and nitrogen by the surface and, by diffusion, create a concentration gradient. The process is completed by cooling at a rate that produces the desired properties in the workpiece. Carbon steel, which is essentially iron plus carbon with no intentionally added alloy. Also known as ordinary steel, straight carbon steel, or plain carbon steel. Carburizing absorption and diffusion of carbon into solid ferrous alloys by heating, to a temperature usually above Ac 3, in contact with a suitable carbonaceous material, a form of case hardening that produces a carbon gradient extending inward from the surface, enabling the surface layer to be hardened either by quenching directly from the carburizing temperature or by cooling to room temperature, then re-austenitizing and quenching. Case. The surface layer of a steel whose composition has been changed by the addition of carbon, nitrogen, chromium, or other material at high temperature. Case hardening. A generic term covering several processes applicable to steel that change the chemical composition of the surface layer by absorption of carbon-nitrogen, or a mixture of the two and, by diffusion, create a concentration gradient. The processes commonly used are carburizing and quench hardening, cyaniding, nitriding, and carbonitriding. The use of the applicable specific process name is preferred. Cementite. The common name for iron carbide, Fe3C, the chemical combination of iron and carbon. Chemical vapor deposition, CVD. The deposition of a coating by means of a chemical reaction in gases in a chamber producing components which deposit on and adhere to the substrate. Chromating. Chromate conversion is a process which completely degreases and removes all traces of the oxide film, replacing it by immersion, a rinse, with chromate coating which can then be painted. It is used as a post-treatment for cadmium, zinc, and aluminum coatings. Chromizing high temperature, approximately 9,000 degrees Celsius pack or gaseous diffusion of chromium into the surface of a component to enhance high-temperature corrosion and oxidation resistance. Coating, the application of a thin, generally less than 1 millimeter layer of material onto the surface of a substrate. Cold working, plastic deformation of a metal at a temperature low enough so that recrystallization does not occur during cooling. Controlled atmospheric furnace, heat treatment. Furnace used for heat treatment of tool steels where the atmosphere is generated outside the furnace and introduced into the heating chamber in such a way as to allow positive control. One of the distinguishing features of this furnace is that the moisture content of the atmosphere is controllable. The presence of water vapor in the furnace will have a profound effect on both the tendency for decarburization and scaling. These atmospheres are almost always produced by endothermic generators. Core. The interior part of a steel whose composition has not been changed in a case hardening operation. Corrosion. Chemical or electrochemical reaction between a metal and the local environment, whether wet or dry, which results in deterioration in the properties of the metal. Critical cooling rate. The rate of continuous cooling required preventing undesirable transformation. For steel, it is the minimum rate at which austenite must be continuously cooled to suppress transformations above the Ms temperature. Critical point. A temperature point at which a structure change either starts, is completed, or both when a material is being heated or cooled. Critical range. The temperature range between an upper and lower critical point for a given material. Critical temperature. That temperature during heating at which a phase transformation takes place and austenite is formed. Same as critical point or transformation temperature. Deposition decarburizing the process, usually unintentional, of removing carbon from the surface of a steel, usually at high temperature, when in contact with certain types of atmospheres. Diamond-like carbon. A thin carbon-based coating applied by either PVD or PACVD. It has high hardness and low friction. Diffusion, 1. Spreading of a constituent in a gas, liquid, or solid tending to make the composition of all parts uniform. The spontaneous movement of atoms or molecules to new site within a material. Dissociation. The chemical breakdown of a compound into simpler compounds or elements. One of the most common examples is the dissociation of ammonia, NH3, into nitrogen and hydrogen. Draw. The common term used interchangeably with tempering. Electroless nickel. The autocatalytic deposition of nickel, phosphorus, and nickel boron have many useful corrosion and triboro corrosion applications. Unlike the electrolytic processes, they produce a deposit with completely uniform coverage. In the case of Ni-P, deposits around 25 to 50 microns thick with a hardness of about 500 HV is obtained, but thermal aging at temperatures around 400 degrees Celsius can develop hardness values more than 1000 HV.
Electroplating. The application of a layer of metal onto a substrate in a conducting solution of metal slats. Embrittlement. Reduction in the normal ductility of a metal due to a physical or chemical change. Examples include blue brittleness, hydrogen embrittlement, and temper brittleness. Equilibrium diagram. A graphical representation of the temperature, pressure, and composition limits of phase fields in an alloy system as they exist under conditions of complete equilibrium. In metal systems, pressure is usually considered constant. Equitip hardness tester. A portable hardness tester which takes measurements on the surface of metals in L values which read directly from the digital display unit. This tester reports L value hardness by measuring a velocity change when a spring-propelled tungsten carbide test tip impacts a metal surface and rebounds therefrom. Conversion curves have been developed for steel, which permit the L value to be displayed in the conventional Rockwell, Brunel, Vickers, and Shore hardness scales. Erosion. Removal of material from a surface caused by the flow of particles within a liquid or gas. Eutectoid 1. An isothermal reversible reaction in which a solid solution is converted into two or more intimately mixed solids on cooling, the number of solids formed being the same as the number of components in the system. 2. An alloy having the composition indicated by the eutectoid point on an equilibrium diagram. 3. An alloy structure of intermixed solid constituents formed by a eutectoid reaction. Exothermic reaction or material. Certain materials undergo chemical reactions when heated in an arc or plasma and produce extra heating. This can be useful in improving adhesion of the coating to the substrate. There is also a potential explosive or fire hazard when handling powders which are exothermic. Fatigue. Failure by progressive fracture caused by repeated applications or reversals of stress. Ferrite is the name given any solid solution in which alpha iron is the solvent. Ferrite is strictly a structure name and means nothing as to composition.
File hardness. Hardness is determined using a file of standardized hardness on the assumption that a material that cannot be cut with the file is as hard as, or harder than, the file. Files covering a range of hardness may be employed. Flame hardening, surface hardening. A controlled process consisting of heating a desired area, localized, with an oxyfuel burners to high temperature, and then quenching to produce a desired hardness. Several types of flame hardening are available: spot stationary hardening, progressive spinning, and drop quench. Full annealing. An imprecise term that denotes an annealing cycle to produce minimum strength and hardness. For the term to be meaningful, the composition and starting condition of the material and the time-temperature cycle used must be stated. Galling. Damage to the surfaces of materials sliding in contact with each other, usually caused by the localized welding together of high spots. Common for materials like stainless steel, aluminum alloys, and titanium. Galvanizing, a hot dip process for deposition of zinc for galvanic corrosion protection of steel. Grain growth. Growth of some grains at the expense of others, resulting in an overall increase in average grain size. Grain size. For metals, a measure of the areas or volumes of grains in a polycrystalline material, usually expressed as an average when the individual sizes are uniform. In metals containing two or more phases, the grain size refers to that of the matrix unless otherwise specified. Grain sizes are reported in terms of number of grains per unit area or volume, average diameter, or as a grain size number derived from area measurements. Hardenability. The fundamental characteristic of a steel which determines the ease of preventing the transformation of austenite to anything else but martensite during the quench. Hard chrome plating. The electrolytic deposition of chromium to form a very hard 1000 HV, tough acting with good wear resistance. The structure is micro-cracked. Hardening. Increasing hardness by suitable treatment, usually involving heating and cooling. When applicable, the following more specific terms should be used: age hardening, case hardening, flame hardening, induction hardening, precipitation hardening, and quench hardening. Hardness. Test. a test designed to assess the resistance to penetration from a load. The surface is indented under a defined load, and the depth of penetration is observed. Heat treatment. Heating and cooling a solid metal or alloy in such a way as to obtain desired conditions or properties. Heating for the sole purpose of hot working is excluded from the meaning of this definition. Homogenizing and annealing treatment at fairly high temperature designed to eliminate or reduce chemical segregation. Hydrogen embrittlement. The brittleness induced in steel by the absorption of hydrogen, most commonly from a pickling or plating operation. Inclusions. Particles of impurities, usually oxides, sulfates, silicates, and such, which separate from the liquid steel and are mechanically held during solidification. In some grades of steel, inclusions are made intentionally high to aid masonability. Induction. Hardening. A form of hardening in which the heating is done by induced electrical current. The localized surface heating of a medium carbon steel by an induction coil so that the temperature is raised above 9,000 degrees Celsius. The part is quenched or self-quenches by virtue of the remaining cool bulk of the component and tempered to produce a martensitic structure at the surface. Ion implantation. A process in which a beam of positive ions is projected towards and into the surface. It is carried out in partial vacuum, and the ions diffuse into the surface layer of the substrate. Typically, this is carried out with nitrogen, giving a nitride effect. Interrupted quench. Stopping the cooling cycle at a predetermined temperature and holding at this temperature for a specific time before cooling to room temperature. Usually done to minimize the likelihood of cracking or to produce a particular structure in the part. Isothermal treatment. A type of treatment in which a part is quenched rapidly down to a given temperature, then held at that temperature until all transformation is complete. Jominy test. See and quench hardenability test. Laser alloying. The application of a powder to a surface followed by fusing and alloying into the surface via the heat from an impinging laser. Laser glazing. The melting and quenching of a surface to form a fine-grained structure or glaze. Laser. Hardening the localized surface heating of a medium carbon steel by an incident laser so that the temperature is raised above 9,000 degrees Celsius. The part is quenched or self-quenches by virtue of the remaining cool bulk of the component and tempered to produce a hard martensitic structure at the surface. Magnetron sputtering C. Sputtering. In this PVD process, the sputtering action is enhanced by intense magnetic fields. Martempering or marquenching. Martempering is a form of interrupted quenching, in which the steel is quenched rapidly from its hardening temperature to about 450 degrees Fahrenheit, held at 450 degrees Fahrenheit until the temperature is uniform, then cooled in air to room temperature. Actual hardening does not occur until the air cooling starts and is accomplished with a minimum temperature differential. Martempering is indicated for low to medium alloy steels when distortion may be a problem. Martensite. The very hard transformation product which forms austenite when a steel is quenched and cooled below about 450 degrees Fahrenheit. Technically, martensite can be a supersaturated solution of carbon in tetragonal distorted cubic iron. Under the microscope, it appears as an acicular or needle-like structure. Hardness of martensite will vary from Rockwell C30 to Rockwell C68, depending on the carbon content. Mechanical bonding. Usually represented by mechanical interlocking of the deposited particles with the rough heights on the substrate surface produced during grit blasting. Metallurgical bonding, produced by chemical bonding between areas of the coating and substrate in intimate contact, or even by diffusion interaction between the coating and substrate. Metallurgical bonding can be enhanced by post-spraying diffusion heat treatments. Micro hardness. The hardness of a coating is measured on a microscopic scale. Microstructure. The structure of a metal as reveled at high magnification, usually at 100x and higher. Nickel plating. The electrolytic deposition of nickel to form a corrosion barrier or to reclaim a worn part. Can also include hard ceramic particles to form a wear-resistant composite coating. Nitriting. The process of adding nitrogen to the surface of a steel, usually from dissociated ammonia as the source. Nitriting develops a very hard case after a long time at comparatively low temperature, without quenching. Nitrocarburizing. Any of several processes in which both nitrogen and carbon are absorbed into the surface layers of a ferrous material at temperatures below the lower critical temperature and by diffusion create a concentration gradient. Nitrocarburizing is done mainly to provide an anti-scuffing surface layer and to improve fatigue resistance. Compare with carbonitriding, normalizing the process of heating steel to a temperature above its transformation range, followed by air cooling. The purpose of normalizing may be to refine grain structure prior to hardening the steel, to harden the steel slightly, or to reduce the segregation in castings or forging. Overheating. Heating a metal or alloy to such a high temperature that its properties are impaired. When the original properties cannot be restored by further heat treating, by mechanical working, or by a combination of working and heat treating, the overheating is known as burning. Oxidation. Chemical reaction between the surface elements and oxygen causing oxides of the elements to be formed. Oxidizing. The production of a stable oxide layer on a steel component by heating in a controlled atmosphere. Provides corrosion protection and reduced friction. Passivating the post-treatment, usually by chromatin of nickel, cadmium, or zinc coatings to reduce their corrosion rates. Pearlite. A metastable lamellar aggregate of ferrite and cementite resulting from the transformation of austenite at temperatures above the bainite range. Phosphating. A conversion treatment to produce a thin phosphate-based layer on a steel surface, providing improved corrosion protection. Physical vapor deposition. A term covering all the vapor deposition processes including ion plating. It does not include CVD as this is chemical, not physical. Plasma nitriting, also called ion nitriting. A vacuum glow discharge technique of nitriting. See nitriting. Porosity. The presence of pores or voids in a coating whether connected or not. Porosity is not the same as pullout. Precipitation. Hardening. Hardening caused by the precipitation of a constituent from a supersaturated solid solution. See also age, hardening, and aging. Preheating. Heating before some further thermal or mechanical treatment. For tool steel, heating to an intermediate temperature immediately before final austenitizing. For some non-ferrous alloys, heating to a high temperature for a long time, to homogenize the structure before working. In welding and related processes, heating to an intermediate temperature for a short time immediately before welding, brazing, soldering, cutting, or thermal spraying. Quality control. All aspects of the control of the heat treatment process, including the surface preparation, heat treatment, process control, tests as specified. Quenching. Cooling from high temperature, usually at a fast rate. Recarburize. 1. To increase the carbon content of molten cast iron or steel by adding carbonaceous material, high-carbon pig iron, or a high-carbon alloy. 2. To carburize a metal part to return surface carbon lost in processing, also known as carbon restoration. Rockwell hardness test. An indentation hardness test based on the depth of penetration of a specified penetrator into the specimen under certain arbitrarily fixed conditions. Secondary hardness. The higher hardness developed by certain alloy steels when they are cooled form a tempering operation. This should always be followed by a second tempering operation. Size distribution. The distribution of sizes within a size analysis. The distribution may be normal or skewed in some way due to the powder manufacturing process. Solution treatment. Heating an alloy to a suitable temperature, holding at that temperature long enough to cause one or more constituents to enter solid solution, and then cooling rapidly enough to hold these constituents in solution. Spalling, the lifting or detachment of a coating from the substrate. Spheroidizing, a heat-treating process used to change all the carbides in steel to rounded particles, or spheroids. A completely spheroidized structure is the softest and most workable structure for any composition. Sputtering. This is a glow discharge process whereby bombardment of a cathode releases atoms from the surface, which then deposit onto a nearby target surface to form a coating. Stabilizing treatment 1. Before finishing to final dimensions, repeatedly heating a ferrous or non-ferrous part to or slightly above its normal operating temperature, and then cooling to room temperature to ensure dimensional stability in service. 2. Transforming retained austenite in quenched hardenable steels, usually by cold treatment. 3. Heating a solution. Treated stabilized grade of austenitic stainless steel to 870 to 900 degrees Celsius to 1,600 to 1,650 degrees Fahrenheit to precipitate all carbon as titanium carbide, niobium carbide, or tantalum carbide so that sensitization is avoided on subsequent exposure to elevated temperature. Stopping off. 1. Applying a resist. 2. Depositing a metal, copper for example, in localized areas to prevent carburization, decarburization, or nitriting in those areas. Strain, a measure of the extent to which a body is deformed when it is subjected to a stress. Stress, the force per unit area on body that tends to cause it to deform. It is a measure of the internal forces in a body between particles of the material of which it consists of, as they resist separation, compression, or sliding. Stress relieving. Heating to a suitable temperature, holding long enough to reduce residual stresses, and then cooling slowly enough to minimize the development of new residual stresses. Substrate, the parent or base material to which the coating is applied. Surface hardening, a generic term covering several processes applicable to a suitable ferrous alloy that produces, by quench hardening only, a surface layer that is harder or more wear-resistant than the core. There is no significant alteration of the chemical composition of the surface layer. The processes commonly used are induction hardening, flame hardening, and shell hardening. Use of the applicable specific process name is preferred. Surface preparation. Cleaning and roughening the surface to be sprayed, usually by grit or bead blasting. This is to increase the adhesion of the coating to the substrate. Tarnish. Surface discoloration of a metal caused by formation of a thin film of corrosion product. Temper 1. In heat treatment, reheating hardened steel or hardened cast iron to some temperature below the eutectoid temperature for the purpose of decreasing hardness and increasing toughness. The process also is sometimes applied to normalized steel. In tool steels, temper is sometimes used, but inadvisably to denote the carbon content. In 3. In non-ferrous alloys, and in some ferrous alloys, steels that cannot be hardened by heat treatment. The hardness and strength produced by mechanical or thermal treatment or both, and characterized by a certain structure, mechanical properties, or reduction in area during cold working. Temper brittleness. Brittleness that results when certain steels are held within, or are cooled slowly through, a certain range of temperature below the transformation range. The brittleness is manifested as an upward shift in ductile to brittle transition temperature, but only rarely produces a low value of reduction of area in a smooth bar tension test of the embrittled material. Temper color. A thin, tightly adhering oxide skin, only a few molecules thick, that forms when steel is tempered at a low temperature, or, for a short time, in air or a mildly oxidizing atmosphere. The color, which ranges from straw to blue depending on the thickness of the oxide skin, varies with both tempering time and temperature. Tempered martensite. Embrittlement. Embrittlement of ultra-high-strength steels caused by tempering in the temperature. Ange of 205 to 4,000 degrees Celsius, 400 to 7,500 degrees Fahrenheit, also called 3,500 degrees Celsius, or 5,000 degrees Fahrenheit embrittlement. Tempered martensite embrittlement is thought to result from the combined effects of cementite precipitation on prior austenite grain boundaries, or interlath boundaries, and the segregation of impurities at prior austenite grain boundaries. Temper. Embrittlement. Embrittlement of alloy steels caused by holding within or cooling slowly through a temperature range just below the transformation range. Embrittlement is the result of the segregation at grain boundaries of impurities such as arsenic, antimony, phosphorus, and tin. It is usually manifested as an upward shift in ductile to brittle transition temperature. Temper embrittlement can be reversed by retempering above the critical temperature range, then cooling rapidly. Tensile strength. A measure of the resistance that a material offers to tensile stress. It is defined as the stress, expressed as the force per unit cross-sectional area required to break it. Tensile stress. Axial forces per unit area applied to a body that tend to extend it. Thermal embrittlement. Intergranular fracture of miraging steels with decreased toughness, resulting from improper processing after hot working. Thermal embrittlement occurs upon heating above 10,950 degrees Celsius, 2,000 degrees Fahrenheit, and then slow cooling through the temperature range of 815 to 980 degrees Celsius, 1,500 to 1,800 degrees Fahrenheit, and has been attributed to precipitation of titanium carbides and titanium carbonitrides at austenite grain boundaries during cooling through the critical temperature range. Thermocouple, a device for measuring temperatures, consisting of lengths of two dissimilar metals or alloys that are electrically joined at one end and connected to a voltage measuring instrument at the other end. When one junction is hotter than the other, a thermal electromotive force is produced that is roughly proportional to the difference in temperature between the hot and cold junctions. Trustite, obsolete. A previously unresolvable, rapidly etching fine aggregate of carbide and ferrite, produced either by tempering martensite at low temperature or by quenching steel at a rate slower than the critical cooling rate. Preferred terminology for the first product is tempered martensite, for the latter, fine pearlite. Wear, loss of material from a surface by means of relative motion between it and another body. Work hardness. Hardness developed in metal resulting from cold working. Zero defects. Achieving zero defects in heat treatment means ensuring every component meets exact specifications with no deviations. This requires precise process control, regular equipment maintenance, thorough quality checks, and skilled personnel. By focusing on continuous improvement and root cause analysis, zero defects enhance product quality, reduce costs, and build trust in the industry. It's a commitment to excellence in every step. Critical points. Phase diagram. ACM A1, A3, A4. Same as ACM AL, A3, and A4. The temperatures of phase changes at equilibrium. ACM in hypereutectoid steel, the temperature at which the solution of cementite and austenite is completed during heating. ACL, the temperature at which austenite begins to form during heating. AC3, the temperature at which transformation of ferrite to austenite is completed during heating. AC4, the temperature at which austenite transforms to delta ferrite during heating. AECM, AL, A3, A4, defined under transformation temperature. ARCM and hypereutectoid steel, the temperature at which precipitation of cementite starts during cooling. ARL, the temperature at which transformation of austenite to ferrite or to ferrite plus cementite is completed during cooling. R3, the temperature at which austenite begins to transform to ferrite during cooling. R4, the temperature at which delta ferrite transforms to austenite during cooling. R, the temperature at which transformation of austenite to pearlite starts during cooling. F, the temperature at which martensite formation on cooling is essentially finished. See transformation temperature for the definition applicable to ferrous alloys. Ms, the temperature at which martensite starts to form on cooling. See transformation temperature for the definition applicable to ferrous alloys. Thank you for watching. I hope you found this video on A to Z of heat treatment terminology helpful and informative. If you enjoyed the content, don't forget to hit the like button and subscribe to the channel for more in-depth heat treatment tips and techniques. For a complete guide on heat treatment processes from A to Z, make sure to check out our Heat Treatment Series playlist. You'll find everything you need to know about metallurgy, management, and much more. Thanks again for tuning in, and I'll see you in the next video. Until then, stay safe and keep learning about heat treatment.